Hi there, I'm John from CNCKing.com, and today we'll make a huge custom firm mold. There's a little bit of false perspective going on here with this mold. This mold is made out of fir, which is 2x6s, and I believe they were 10 feet long, and I cut them in half. So the size of this is 5 feet across, and it's about 3.5 feet high, and a little bit more than 5 inches thick. So it gives you an idea of just how massive this thing is. As for the weight, it's roughly, I'd say, around 100 pounds. It lost quite a bit of weight during the machining process. And as you see, there was sawdust absolutely everywhere in the shop from doing this. There's an incredible amount of dust that this wood chipper makes when it really starts going through the material. Now, when making something like this here, it's very, very important to have a very rigid machine, which is what I have. I can't think of myself ever doing a mold like this here with something with the gantry moving. And the reason for that is because the bit that I use to cut this out with is 6 inches. Let me just show you. So this is what a 6-inch long bit looks like here. And typical bits I use with my router are 3.5. So it gives you an idea of just how big the bits are. And the challenge with that is that I'm cutting stuff here, but it's spinning up here. So that distance can cause bit deflection, a bunch of other issues that can happen. And it means the bit really wants to break on you. And I've broken a ton of bits doing this kind of work. And the longer the bit, the more it wants to break. Regardless of the process that we do here in the shop for our customers to make a final product, it's kind of fun because it's always step by step by step, and that's the way you get through these kind of jobs. If you just look at the whole mold finished thing right off the bat, it's kind of overwhelming, to be honest. But again, just take it step by step, whether I'm welding, whether I'm machining, whether, whatever I'm doing. In this case here, I'm cutting off the 2x6s to a certain size, because I know the size of the finished mold, and I always add a couple of inches X and Y and Z, so I have a little bit of give, for putting screws and stuff that happens. And when I do that, I have nice, perfectly sized boards. The problem is 2x6s are like 2x4s, and they're absolutely never flat. So that's what I'm doing here. I'm flattening both sides of it. And this is a very important step because when you glue it together, you want a seamless glue. And I've tried a bunch of different ways of doing this, and by far the best way to do it is using the CNC machine to flatten it. It's relatively fast. It'd be definitely faster to use a regular planer, which I do have in the shop, to do this. And it'd be a lot more cost effective too, but the CNC just does such a wonderful job of it that I just do all the molds this way since I started making actually custom oak banks a couple of years ago. And that process is the same as making molds, same process as a bunch of other stuff. So the process here is just load them up, flatten the top and the bottom, and then move it over to the other side until I have the perfect size mold that I need for the job. Now after that, what happens is I actually have to flatten the top and the bottom of that finished mold as well. So I end up actually flattening every side of the 2x6s. Well, when it comes to gluing up here, I wanted one solid mold, and this is actually the last time I do a mold like this. And the reason is because it took so long to glue it, I was really concerned that where I started off was starting to dry on me before I was finished doing the mold. And that's a bad thing because when you squish it together, if it's already dry, well, you're not actually helping with the adhesion at all. Now in this case here, it worked out fine, but from now on, I've made them half and half. And then after that, the next day or two down the road, what I do is I glue that together, and then I got the finished mold. Now when it comes to making molds like this as well, one thing that does go into your favor is the weight. This was easily over 200 pounds when it was solid. What makes it heavy is about 2 big things of glue, basically to stick it all together, and the weight of the material itself. Now of course I flattened it, I got some weight off that way, but it's very minimal compared to the overall mold. Now the reason why customers want molds like this is because number one, it's fir, so it's a very cost-effective material. I love using this material for molds because it's relatively easy on bits. If I was making this out of, let's say, black walnut or oak or zebra wood or what have you, we can totally do it. It's not a problem. Machine time would be horrendous. Carrying it back and forth and stuff, it'd be like 2 or 3 times the weight. Again, you want to have the best thing you can possibly have. And the other nice thing about fur molds like this here is that at their shop, they're able to further sand it, clean it up, and do other things to it relatively easily. It's basically 2x4s, right? So if you're sanding a 2x4, you know how easily it sands. And for thermoforming, that's totally fine because you add a little varnish on it, you clean it up, you do a bunch of stuff to help it. But it's really good for heat dissipation as well. So here you can see me flattening the top, and after that I will flatten the bottom. And again, that's how you get all 4 sides totally flat, totally parallel. Perfect mold to start making the mold with. If you don't have a good blank, you end up with a crappy mold. I've found that out the hard way. And again, this takes several days to get all this stuff done and sorted out to have nice blank working. But the results are just amazing, and I wouldn't do it any other way. Now you will notice that I got a bunch of glue on my table. And the reason for that is because my shop is relatively small and I don't have a table that I could use just for glue. And I found, I gotta flatten the table anyways before I do a mold, because I wanna make sure my X, Y, and Z are everything totally, again, dead flat and parallel. If your table is not flat and parallel, well then the mold you make is not flat and parallel, even if the mold is flat and parallel. So I have to do this process anyway. So I figured, well, I might as well just use my table to glue everything up. Yes, I have glue all over the table, but here what I'm doing is skimming it all off anyways. To produce a flat table, and it just works wonderful. So that's what I've been doing since then. You'll notice at the bottom left there I got a bunch of scrap metal. I'm doing quite a bit of welding on the side, and I got lots of little pieces, offcuts and all that kind of stuff. So I'm just building them up slowly, and whenever I got jobs, it works out perfect to have that. Again, when you have a relatively small shop, everything sort of fits with everything else, and you make do with what you have. So what I'm doing here is vacuuming the top, because what you don't want is a little piece of sawdust or whatever you have after skimming, after glue, or a little piece of glue would actually be worse because it's hard. And what happens is it goes under the molds. So I think my mold is flat and parallel. Well, actually it's being lifted by one corner with something. And the problem with that is that if it's lifted on one side, when I flatten it again, guess what? I'm out of spec right off the bat. Now you'll notice you'll notice here there's a hole, there's a hole. I didn't bother doing another hole here. Basically I have a massive vacuum system that I cover the whole bed of my 5x10 router with. And then I stick this thing on it, which has just been flattened, so it's dead flat. And then I have the vacuum sucking it down. So technically I don't really need the screws. I put them in basically force of habit, just in case something goes wrong. I don't want this thing moving at all, because I'm using multiple bits. So one bit does work. So for instance, if we go back to the large bits here, so before I use this bit here, I want to use this bit. So this bit here is 1/2 inch diameter, and it's a roughing bit. And so I try to do as much as I can with this. I have roughly 2.5 inches. Then the collet is maybe 1/10 of an inch. Clearance. Again, I'm playing things pretty close here. And then after that, this guy's done a lot of work, he's tired. Then I flip over to him to do the rest of the deep carving. Now as for the depth, I go almost 4.5 inches, depending on the spot. So again, this is a 6-inch bit. I'm going 4.5 inches, roughly this. And I have the collet basically here holding it in, spinning it at around 15,000 RPM. So there's a lot of things that can go wrong. And the nice thing about breaking bits that I've found is that generally what happens is they break in the material and the material holds it. It doesn't go flying across the shop, though I did have that happen before. So, that's the way it is. So here I am actually flattening the mold one last time. And this is the back side, which is actually the front side of the mold. I do this right before production, just to make sure nothing moved in the last couple of days. Wood likes to move on you slowly over time. So I want to start off with a dead flat, perfect, absolute perfect blank to work from to make the best mold I possibly can for the customer. Now this table is massive. It's a 5x10 table, and it gives you an idea of just how huge this actual mold is. And it weighs quite a bit. Production is definitely not this fast. I wish it was great, it would be great. But this is sped up tremendously. And basically what I'm doing is going step by step down into the mold to carve out the cavities and the details that the customer needs for their project. At the same time, I'm also checking the work as it's going real time. That's why you see me keep popping up there. I'll clean off the surface, making sure the bit's not broken. I have the chips fine that are the proper, proper chip load and a bunch of other details to work out. I also check the whole model with digital calipers. Again, just to make sure if there's a problem, I can fix it when it happens at the beginning. If I do a completed mold and then I found out it's out of spec, well, basically I have to go through the whole process of making the blank all over again and the mold all over again. So while you're carving down into it, if you find out you're off, by a 1/10 of an inch or something like that, you shouldn't be, but if it were to happen, right away I could account for that. And I have plenty of give on the Z, so the height of the mold, that worst comes to worst, I could recut the mold just a 1/10 of an inch deeper, fix whatever needs to be done, and have, again, a perfectly good mold. Now you can see here how long that bit is. And the longer the bit, the more prone it is to break. And that was a big concern of mine when I was doing this project. And generally speaking, you're fine. The issue is sometimes the bit hits a big chunk of material and it goes from cutting off a 1/10 of an inch everywhere all the way down to cutting 1/2 inch of material. And if it's going at the same speed, guess what? That bit breaks immediately. It doesn't matter if it's a 1/2 inch diameter or a 1 inch diameter, it just breaks. And this machine is so powerful, it absolutely does not care. It just keeps going like nothing happened. And I've had that happen before, and that's why I'm very careful with it. I'm also cleaning all the crap off the mold as I'm doing it, or the sawdust. And again, the reason for that is just to make sure there's no cavities or something like that might be coming up, where I can manually slow down the machine as it carves through the cavity, and then it continues on, it's 1/10. So I knew I had no problem going where you see the machine running now. I had no problems there. I could go full speed. But when it got to the beginning of the mold and the end of the mold, that's where it was kind of tricky. Because again, the software doesn't really have an idea of the thickness or what it's going to go through. But from experience, I found, again, just be careful with it and you produce a perfect mold for the customer. And of course, this is fir, so it's a softwood. So it's an extra bonus for doing this kind of work because it's soft. The chances of breaking the bit are a lot smaller than if this was solid oak. So how do you go about getting a mold like this made? It's pretty straightforward. These are all actually STL files. So they're actually 3D printed or 3D printing files, which I'm very familiar with. And from that, we scale to the right proportion, get the customer to approve, and then we go ahead and make it. As for the material, we can literally make this out of any material. If you wanted this made out of solid resin, what I would suggest is we do it out of fir, and then you make it all pretty, exactly the way you want. And then what you do is you pour the resin into it, and then you remove the wood, and then you have a perfect mold that's very, very hard resin. The reason for that is a couple things. Number one, resin is incredibly heavy. And it's also very, very expensive, the good stuff, of course. And because it's so heavy and that, what you do is you're using just exactly the amount of resin you need to make the mold. So this here's a positive mold. Or a negative mold, if you want a positive one, we just do it the other way. There's no real difference for the machine. We can make it out of oak, poplar, whatever, but I don't know, for something like this here, I think fir is great for most applications. It's very easy to add Bondo to, glue, other stains, finishes, whatever, to make your thermoforming or other applications you need a mold for. So looking for custom molds, contact me at CNCKing.com. We'll make it for you and ship it right to your door.